talking about today very briefly. I'm going to focus in on one particular thing that I showed last night in the demo jam, which is numisma.org and the XForms backend for that. Before I talk about the technical things with XForms, I'll go into some of the issues that we face within the discipline of the study of coins and aggregating data and conducting research on coin data. And just talk about some of the underlying data and how it's structured. And that's kind of an important precursor in actually talking about how we use XForms to manipulate the data. So I'm sure this numismatic data is fairly new to you, so I'll discuss in brief the state of the discipline in terms of description. So this is a Greek word, it's a denarion. So one of the fundamental problems we have in numismatic research is that each country or museum may have its own database of coins, and these databases are authored natively in the language of the country that produces the database. So this word denarion has different labels in different languages. Scholars all fundamentally agree that this is the Greek label for a denarius, which is the most common Roman silver coin that was in circulation for about 400 years. And so we began to adopt linked data methodologies in 2010 to ameliorate some of these problems with different languages and different labels for fundamentally the same intellectual concept within numismatics. So a denarius is represented by a URI. And if you go to numisma.org/id/denarius, you'll get a web page back. And it's a human-readable web page that is serialized from some machine-readable RDF underneath, but you can also request machine-readable data through content negotiation and through REST as per standard procedure for linked open data systems. I'll talk a bit about what a coin type is. So numisma.org currently it's mainly focused on Greek and Roman right now, but we are expanding into medieval numismatics and Islamic numismatics. A coin type is basically a combination of different characteristics into a mostly unique typology. So there are many thousands of URIs that have been minted in numisma so far, and many tens of thousands of additional URIs have been minted by other partner projects to describe typologies. So this is a coin type. It's silver. It was manufactured by striking, so it was like a mostly melted piece of silver that was stamped with a wooden block that had been carved to form this iconography. It was minted in Emerita, which is in Spain, a Roman city in Spain. It's a denarius. It was issued by the Emperor Augustus, and it has words on the front and back that are called a legend, and there's iconography on the front and back of the coin. So in terms of numisma concepts, then, we have URIs for most of these intellectual concepts. So material has a URI in numisma, and mint and denomination and so forth. And the legend and the iconography are generally represented as literals. These coins traditionally have been thematically arranged and numbered in printed volumes. So, and this has been standard practice in numismatics for about 400 years. So one of the most common printed volumes for Roman imperial coinage is called Roman imperial coinage. It's a 10-volume work that's been published over the last 80 years or so. So when we take all of these individual characteristics of a coin type, we then mint a URI for the typology as a whole, and that numbering system within the URI sort of maps to current standards. So this basically means it's Roman Imperial Coinage, Volume 1, 2nd edition, the section for Augustus, and the number is 4B. So once we mint URIs for all the different typologies of Roman Imperial Coinage, for example, that paves the way for us aggregating content from other museum databases, regardless of what language the database is in, because Roman Imperial Coinage is an accepted reference work throughout the entire numismatic community. So fortunately, there's a lot of standard practice in inserting these basically text strings into bibliographic fields and databases. So with some regex, you can basically map most databases to a URI programmatically, which is very useful. So that allows us then to aggregate content from Berlin and the British Museum and our own collection, plus archaeological databases and that sort of thing. So this paves the way for making projects about Roman Imperial and Republican coinage. The browse page on this is it's a screenshot. It's basically a Solr query that responds in XML, and that's piped through XSLT into HTML. But on the right side, users that are on our system don't realize, but there's so much Sparkle happening underneath that the aggregation is done through Sparkle, through a Sparkle endpoint. So there's a mixture of traditional XML technology and semantic web technologies mixed together into one cohesive interface. This allows us to create maps and timelines, so these maps and timelines are also generated by Sparkle. It allows us to show examples of a particular typology from all the physical specimens that we've harvested through partner institutions. And this is all Sparkle, of course. It also allows us to harvest measurement data from partners and perform more sophisticated analyses, so we can observe the average weight of the denarius over 200 and something years and see how the weight changes over time. As you can see, as we get into the 3rd century, in the beginning on the left side, this is Augustus, and the weight is relatively standard, and then it kind of drops off a bit until they discontinue issuing the denarius, and then it's replaced with something that is theoretically supposed to be worth twice as much, but the silver content declines over time. So this is a period of extended inflation, basically, when you have a coin that is less and less silver, but people start to value it less and less as well. So basically the backbone for all of this is numisma.org, which was launched in 2010 and has evolved considerably over the last 5 years or so. So we have a URI for a denarius, and we expose denarius as machine-readable data. In Turtle, we have a series of triples. So there's a URI, and the URI has pref labels and SCOS, which is an ontology for constructing thesauri. So we can have as many preferred languages as we want in as many languages as necessary, so this facilitates multilingual interfaces. It's a type of denomination, which is from our own ontology. We use Dublin Core terms a lot. It's part of Roman numismatics, which is basically just a category. Has a material of this URI, which is silver, and we use SCOS to perform to create matching URIs and other thesaurus systems, which is really fundamental to aggregation. This is an exact match within the Getty Museum's own vocabulary systems, which have been recently published as linked open data as well. We use a lot of really common ontologies on the web. Try to be as open as possible when doing so. We use SCOS and Dublin Core terms. Those are used everywhere. The organization ontology, FOF, geographic ontologies, some SciDoc CRM, which is a conceptual reference model for museum objects, the biographical ontology. And then we created our own ontology, which fills in gaps because we want to express our data in terms that make sense to our own scholarship. So we basically created an ontology that fills gaps with the sort of semantic language that we need for performing our own sort of queries. So I don't know how visible this is, but so we use XForms to create and edit RDF XML. This is a really important advancement that I implemented shortly after getting hired by the American Numismatic Society in 2011. So when Numisma was launched in 2000 or so, it was built on a wiki software. And all of the linked data was XHTML embedded with RDFA attributes. And the XHTML was hand-coded by 2 scholars, and there's no validation whatsoever. And so you could put malformed XHTML into this wiki software and it completely break the page. So that was completely unacceptable for any sort of information system. So at first we introduced XForms for modifying XHTML fragments with the RDFA and embedded. Then we migrated simply to using RDF XML natively, which was a lot more stable. And the paper that I wrote covers all this in greater detail. But we have a number of controls on the left, so you can insert preferred labels and alternative labels and various other sorts of SCOTS properties. You can insert matching URIs in other systems. You can insert other sorts of properties that link these URIs to other URIs, either internally or externally. On the bottom here is a drop-down menu. You can't really see very well, but it's basically when the form is loaded, a Sparkle query is executed to get different fields of numismatics. That populates an instance in XForms, which is then bound to a drop-down menu. So that way we can try to create as good quality of data as possible using XForms controls. There is validation throughout the system. On the right side, we have lookup mechanisms that hook into REST interfaces for various other services, like the Getty Museum publishes a Sparkle endpoint, which we use for lookup mechanisms. And also Wikidata is fundamental to this as well. So suppose I'm creating a new concept and I'm really lazy and I want to pull as much data in from other sources as possible. So Wikidata, I don't know how familiar you are with it, but it's basically a data backend for Wikipedia. And they have well-published APIs that respond in both XML and JSON. And so with a Wikidata lookup, you can just copy and paste a Wikipedia article, and the article is parsed, and then it looks for the article title, the XForms engine does, and then fetches the XML from Wikidata. And then it will pull all of the labels and all of the languages that it has from Wikidata, as well as all of the exact matching concepts that have been embedded into Wikidata, since it's becoming such a powerful tool for co-referencing between different linked data thesauri. So you can go from like having nothing to having something that has many different labels and links to other systems as possible almost instantaneously. The validation is really an important part in all of this. So there must be an English preferred label and one English definition for every concept in Numisma. There can't be more than one language per definition or label, so you can't put 2 English preferred labels in. There can only be one. So this is all done through XForms bindings and XPath basically on the RDF XML document to make sure that everything is completely valid. When creating mints or regions or other sort of geographical features, latitude and longitude have to conform to standard decimal numbers. Certain properties are only available for certain classes of objects, so that means you can't put a latitude and longitude into something that isn't a geographic entity anyway. And no blank content, so no blank labels or anything like that. There are other sorts of validation, but these are really some of the most basic ones that we enforce. REST interactivity is really important, so as I mentioned, we have lookup mechanisms for Wikidata and Getty and British Museum Sparkle endpoint and viaf.org, which is published by OCLC. It's a database of people and corporate bodies. We also have internal services, so when you save an RDF XML file, we interact with our own Sparkle endpoint, so we make updates to Sparkle, so we use the Sparkle update protocol. And also we pass the RDF through a transformation into a Solr XML document, and then that gets posted into Apache Solr, which is a REST interface built on a Lucene index. And we also have lookup mechanisms internally for linking things hierarchically. So we use SCOS properties for hierarchical linking, like SCOS broader and narrower and that sort of thing. So if you want to say that a denomination is part of some other sub-denomination or something like that, there are lookup mechanisms to link everything internally so that we prevent human beings from entering these URIs manually, because that would be a very bad idea. And there are other lookup mechanisms for like linking people to dynasties, linking people to corporate entities and that sort of thing. And that's all done through the org ontology and lookup mechanisms. So our architecture is like this, sort of. We have partner institutions at the top that send us data. We upload data through an administrative interface that's also built on XForms. We use Orbeon. It's the middleware that powers this entire thing. So I don't write anything at all in Java or anything that's really that sophisticated. It's all basically XSLT and XForms and user interface stuff on the front end, JavaScript and CSS. And so we take data from partners, and then the Orbeon XForms-based interface interacts with the underlying Sparkle endpoint. We use Apache Fuseki, which is nice and really easy to use, but any Sparkle 1.1 compliant endpoint will work. We have Apache Solr, which we publish to, that's used to power the browse, the faceted browse interface. We don't have a data store in this project. We use Exist XML database for other projects, but due to the history of this project, we actually save the RDF fragments to the file system and then back them up nightly in GitHub. But the Orbeon engine is able to read and write files to the file system, just as well as reading and writing through REST interfaces. So something I introduced last year was batch publication with Google Spreadsheets. Scholars are really accustomed to doing a lot of data entry stuff within spreadsheets. And they're really useful because you can deal with hundreds or thousands of items in a fairly efficient manner, and it's much easier than manually creating 1,000 concepts in the Misma through the editing interface. The issue with that, though, is that people would send me lists of Numisma IDs to create in the system, and I'd have to write one-off PHP scripts for each of these systems to generate the RDF, and then manually publish the updates through into the Sparkle endpoint. And that was a real pain. So I spent a week developing a system that was more generalizable, that could sort of like remove me from the entire publication process. So Google Sheets is really useful because when you publish something to the web, you can request Atom instead. So you can get Atom XML back from Google. So we had a system where we used Google Sheets, and if some basic tenets are followed when creating these spreadsheets, you can upload the spreadsheet into the system. So if you go to an import Numisma ID interface, you get the key for the spreadsheet and you just copy and paste it in there. And you specify what type of entity you're creating. So suppose you want to create a list of mints or something. You get an interface which reads the Atom XML and then reads all the column headings from the spreadsheet and then allows you to then map the column heading from the spreadsheet optionally to an RDF property that's relevant to that particular type of object you're creating. There's some validation in this part, so you must select one of these columns must be an English preferred label. One of them must be a definition and basic stuff like that. So if you then create a mapping that's valid, then you can click a button in order to validate all the data within the spreadsheet once the mapping is ready. Then the XForms engine will iterate through each entry in the Atom feed, which is every row in the spreadsheet, and make sure that some other basic requirements are met. So there must be a preferred label. There can't be a blank cell within the spreadsheet for a preferred label, that sort of thing. So entire validation scenarios that are not unlike the ones that I showed in the editing interface itself. And if that validation passes, then basically each row will be transformed into RDF XML and written to the file system and then updated or created in the Sparkle endpoint and published to Solr. So basically the entire publication workflow is run through that. So to end on some user interface issues, as I said, we have a large mixture of XML technologies and linked data technologies working together. So there's an aggregation of RDF plus Sparkle results that are piped through XSLT in order to display this interface. You can get the RDF back from the system, which is just basically piping the RDF from file system to the browser. Or you can get Turtle and JSON LD, so that's the RDF pass-through transformation into the relevant serialization. Geographic data, as I showed yesterday, that's a Sparkle query that's piped through, the response is piped through XSLT into GeoJSON. And we have a growing list of data sets in the system. There are about 100,000 physical coins in the system so far, and we have more partners coming online all the time. We've probably doubled in size since a year ago, and we'll probably double by next year. I think in the next 5 to 10 years, we may have millions of Greek and Roman coins in the system, and medieval and Islamic, and who knows what else. So we've made a lot of progress in the last 5 years, and I think it's really picking up steam because once you build the tools and the visualizations and the user interfaces, then scholars they really get on board because they understand how useful and important all of this work is, and so it's an easy sell at that point once you've built the tools. So thank you.
Thank you very much, Ethan. Are there any questions? Steve?
How did you migrate the original key version into your data store?
Well, we wrote XSLT to transform the XHTML fragments into RDF XML. Orbeon is the pipeline system on the front end. Actually, there was a middle step in where we used Cocoon at first, and then I got rid of Cocoon after a little while, and then we use Orbeon now. Basically, just rewrote everything in Orbeon's XML pipelines, and So it didn't really take that long. It's data migration was more difficult than framework migration.
Martinus?
Do you use federated queries?
Do I use federated?
Yeah,
For Sparkle?
yeah.
No, because I think it would be really inefficient to build a system on federated Sparkle queries. So we, all of our partners use the Numisma ontology and model, and they export to us, and we basically load everything into a central triple store. And so all the queries are done on the one triple store.
Cool. Any other questions? Okay, thank you, Ethan.